just re-insist to put it clear. So here is a recursive function, terminal recursive function, and here I've got an annotation. This is not my annotation, it's an annotation that Scala requires if you want it to be fast. That allow Scala to optimize the code in the microprocessor. So if you do this, it's not you will not fail. Just you will run slower, but it's not mandatory. Okay? It's an annotation of Scala. That's why I have to import Scala.annotation.tl because this is an annotation from Scala. Okay? But it's not mine. You have to be clear about that. So, normally I have an exercise, but I think it's time to switch to collection because here was just the basics. I need to introduce the collection. What is a feature that is quite interesting in Scala. Okay? So I think I will switch to collections. So normally you have downloaded the two files and you will have collections. If you don't have to download it, download and do as this morning you do. Okay, download the collections and save it to the appropriate directory and open it in the Spark notebook. I'm waiting a little. Yes? Okay. I can wait. It's okay for everyone? Yes? No? Collections. You download it at the web page I showed you this morning. fd.perso, perso.eisti.fr, and you see several links now, but there is one link named collections, and you download it, you save it to Spark notebook/notebooks, and then it will be recognized on Spark notebook and you can run it. Collections, yes. Collections. Normally, if you don't have, download it. Here, normally here, you will show someone. This one. Collections. Yes. Download it and run it. Download it, save, and run it from Spark notebook. Okay, for everyone? Yes? Can I start? Documents. And then go there, and now there. Refresh. And then anyone have trouble? Oh, it's good. Please, raise your hand if you have trouble. You have trouble? Okay, so I start. in fact, there's many collections. As there's many types, about 46. There's many collections in Scala. Okay? So I will present all the collections because all the collections work exactly in the same way. So one is enough to do. But if you want to achieve performance, you have to choose the right collections because a vector is not the same as a list. A vector, you can access one element in a single time, but you have more, it may be difficult to insert an element in a vector less rather than in a list. It's quite fast to insert one element, but you cannot access in constant time to one element. So you have to choose the right collection, but maybe we can discuss that later. If you have problems about that, I can explain you later on. Just focus on one collection that is here, vector. But first of it, I want to introduce the 4 loops for the first time and for the last time. Because loops are not good. In functional programming, evil. In the second workshop, I will show you a 4 comprehension that is totally different than 4 loops with the same operation. But I just want to introduce loops because I know that everybody uses loops. And then I will show you how to avoid using loops. So there is many ways to generate a sequence in Scala. We can use the operator 2, 0 to 10, will generate the number to 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7. If I say print e plus space, it will print the number 0 to 10. There is another way to generate a sequence of number, the 0 until 10. Two difference if you include or exclude the last number. Okay. Look, the same way for e, lesser, minus, and the range you want to have. And there is a specific class, not a function, it's a class. It's just some, which name range. Range 0, 10. And you can start at the number you want, you can finish at number 1. Here, 2. You can start at 5 until 12, etc. This will generate a sequence of indices and of number. Generally, you use this to iterate over a vector or over an array. Please do not do this in Scala. There is many ways to do different. Many. But to fix things, let's imagine that I want to do the sum of the 10 first number. You have 2 choices for now. Do a recursive function or generate a range of the number you want and do the sum. But if you were attending this morning, you will notice here, I have no choice to use var. And var is not good. So is var not good? And force me to use var. For is not good. Okay? So, don't do this again. I know in Scala you never do it. Okay. But in other language, you have no choice. Because other languages are really poor at that. So if you look at the result, generation using 2 will generate the 0 to 10, 10 include, until 0 to 9, or to 10, 10 exclude. Range, it's exactly the same to until, okay? And after, I can have the sum. Sorry, I think the output is not good. That's better.
Oui, il y a un moment, on met des espèces d'accolades et puis quoi, en haut, le prix. Le premier exemple, tu mets pas d'accolade. En haut, comment le premier exemple?
Because I can avoid using brackets because I have only one expression. I can use it, I can put it or not, like you want. If it's one expression, you do what you want. If you have only one, if there's two expressions or more, you have to put bracket. Okay? So this is loop. This was loop. Vectors. Vectors, your first collection in Scala. It's quite similar to array, but it's implemented roughly different in a computer than the habit in your common language. In your common language, vector on an array is something that's linear. In Scala, a vector is not linear. A vector is a tree of 32 values, and each values can refer to another vector. The impact of this, that the research, the search of an element could be done in log 32. Then in your common language, the research is on log 2. So rather, just with the implementation, it's faster to search. A vector, we can declare a vector like v equal vector and the values we want to put in. Or you can convert a range to a vector. For example, range 0 to 10 points to vector. And it will generate a vector also. I can print directly a vector, print v, will print the vector, and it prints also the value, but also the name of the collections. So you have complete information just with print. To access an element, you use parentheses, v0 is the first element, the vector will start at 0. v1, you cannot access an element that is not present. v50 will provoke an exception. So I will show, you. You have an exception if you have access to an element that is not present. It's normal. And we have two ways to know the size of your vectors. Size or length. Okay. So you can manage easily vectors. But for now, it's not quite different than the other language. What's the advantage of Scala? Here it comes. Because collections have many ways to manipulate it. Every collection works with the same thing. Sometimes there are specialties of collections, but they are always working the same way. So, I create two vectors, v and v1, which are exactly the same. The two vectors is range 0 until 10. Two vectors. In many languages, except in Fortran. V is not equals to v1. When you create two arrays, in many languages, even if they are the same values, they are totally different. not possible. Because if this is a fundamental component of your language, you refer to memory, not to the model. In Scala, as I said before, we refer to model. So, V equal V1, yes, it's the same. It's totally the same. Two vectors with the same value. So, this is the same thing. And Scala will answer true. For me, it's very good thing. I didn't know words are put in memory. I don't want to know that. It's not my problem. The problem of the compilers, yes. But of the computer, okay, but not mine. We have 5 little functions. V drop the first 2 elements. So here I drop the first 2 elements 0, 1. So I have a vector of 2, 3, 4, 5, 6, 7, etc. This is another vector, a new vector. Here I just print it, but I can't say V equals V drop 2. If I want to have V drop 2, it's a new vector. Refer to what it is in mathematics. You're not in the same space. You have 2 dimensions. So there is no way a vector of 10 dimensions is a vector of 4 dimensions. No, you can't put it. So it's exactly the same thing. If you produce a new values, this is a new value. It's not an update of a value. I can take the first 2 with the method take. I can take the L, the first element, which is an element. I access to the first element, or I can take the tail, the rest of the vector, except the first element. That's why here the 0 is not present. And a cool function is split at 3, because this split at 3. We will see later, but this split at 3 requires 2 components. A tube is 2 values in one. Okay. Which compose of the 3 first elements and the second vector, the last element. You can split directly at the indices you want. And this can be calculated by other functions. Okay? Normally you have to write the sum of vectors. I think we could run about time if I let you search. Okay? But if you want to code it, it's very simple. You put your code. And you only have loops, so you use loops. Maybe. For the last time, yes. And I have to be careful about it, because I never use loops, so I will be mistaken. Okay, this is what you will do. I have a vector. Excuse me. Excuse me. But the same thing. So I have a vector. I declare the sum equals to 0, and I iterate on the indices. the 0 to 10, and I take the sum.
This is not the exercise.
First one. Okay? This is the first one. I can even calculate the mean and the max. It's not difficult. Okay? Just. Is it okay? No? I'm too fast? But it doesn't matter. Because you won't do this anymore. If you want for cursor vector, you can read this. I won't use it. Okay? I do not need. Just for your personal interest, you can read and understand. It's very easy to understand. But I'm not convinced of this notation, of this usage of vectors. So let's look to the essential functions of collections. Here, I create a vector of range 0 to mil to thousands to vector. Here, I create a new vector with its shuffle of the previous vectors. Scala, which is a random shuffle, we shuffle a vector and generate a new vector. Then, here we have all the vectors. I don't want to explain all the vectors. Then I create two other vectors, V10 and V10 shuffle, exactly the same thing that the vector V1000 and V1000 shuffles, except there are 10 values. There are 10 values. One order, one unordered.
While a Scala point random shuffle is not in green.
It's not in green? I don't know. Because the syntax coloration is not powerful in this environment. It's a function. And I create also a function f that will generate random number. Okay? So I have one function f that will generate a random number, and I have four vectors, two V10 shuffles contain only 10 values, one order, one unordered, and V1000 and V1000 shuffles, which is order, one and order with 1000 values. Okay? For everyone? How can I calculate the sum? The sum of this? It's very difficult. Yes? Just use the function sum. V10 dot sums. Compute the sums. Why you use loops? You don't have to. And you do this, there's the same thing. And I can even use magic keywords. Which is dot par. V10, the dot par, dot sum. Which means the vector in parallel do the sum. Wow.
Very difficult.
Still one.
One word to achieve parallelism. Very difficult. Yes? And this is faster. C'est pas des dossiers. Wow. Okay? Just using the par word and your collections, your computations are run in parallel.
2 times faster. 2 times faster in my computer.
Maybe it depends on your core. It depends on your core. If you have 4 cores, it's roughly near 4 times faster, but it depends on your core.
Like I did maybe the simple calculation. Here with the print 3 times sum, here about 2 seconds. And if we add the parts, it's maybe 1 second.
So it's 2 times faster without effort. Without any effort. Just think, I could calculate the sum more well. Magic. And on every correction, you have the dot par. So when you want to be faster, use dot par. Maybe sometimes, if you have complex calculations, dot par could be not as efficient as on simple corrections, but it's always as efficient as a normal correction.
But I don't feel the difference. I don't feel the difference between with and without that part. I mean, it's faster.
Yes, with par, you distribute the calculation, the computation on all your core of your computers. Without the par, you use one single core.
One single core. Okay. So if we have more data, we can use it.
Yes.
Faster.
More you have data,
Yes.
more the dot bar is good to use. Okay? Next function, which is for me a vital one, the map function. Map function apply a function on every element of your collections. So, if I want to use times 2 on my vectors, so I want to multiply by 2 all the elements of the vector. Before, you were doing loops for E, 0, 2, 10, V the E equals to V the E times 2. So, here we have a function to do this. Vtest.map parenthesis underscore times 2. This is an anonymous function. Here, that is exactly the same. I will explain the difference. I can use the dot notation, v point map parenthesis underscore 2, underscore times 2. Underscore refer to the element that will be taken from the vectors, from the collections. But I do not need a name. So I put underscore. If I want to name it, I can, like in this example. But it's useless. I don't have to name x to say at x, I apply the function fx. I just have to apply f. X is I don't know how to say in English. It's useless. Okay. If you don't want to like a dot notation, you can use it as an operator, as I showed you this morning. V10 space map space. I will add a bracket underscore time to need the difference. The dot notation is really you are calling functions, So you need parentheses. But here we are using no parameters. It's clearly the same thing on the computer, on the language, but it's just syntactic sugar for a person who like dot notation or operator notation. But here you have to change the parentheses by brackets. The only effort you have to do. But you can if you have a function, as I have defined before, I can map f on bit. Because f is taken one element and need only one element, Scala is capable to apply it on all the elements of the vector with the function map. And as I explained to you just before, if I need, sometimes I need, I can name the parameters b, then map, bracket, equal x, bracket x, sorry, and this will name an element of your application, and this you can use it in the definition of what your expression is, what you want to do on your collection. Here, on my collection, I want to apply the function f. Okay? This is clear for everybody? Yeah? So, tell me, why do you need loops? There is no loops. It's useless. Okay? But there is more and more function. Quickly, I will introduce for each. For each is exactly the same that map, except for which doesn't produce results. Map, when you map a function on the collections, it returns the collections with the function applied to every element. Here, for which will call the function on one element, but doesn't produce a result. Typically, we use for each to print. If I want to print, we then for each f. Okay. Now, here I will apply the for each function f. I will apply f on all elements, and it will produce nothing unique because with for each doesn't produce results. Here I call on for each I call x. The definition will print x plus. It produces this one, print, but no result of the value. There is no result, unique result, for the values of the expression for each. Map produces the result of the same type that the collection you enter, and for each doesn't produce results. The only difference. Filter. I can filter easily a collection. Then filter underscore modulo 2 equals to 0. I select only the even number. And this produces a vector of the even number. Filter don't exist if you want. Sometimes it's more difficult to explain the good conditions, so you can explain the bad condition and filter not is bad condition. Magic. Okay for filter? Okay? No, so we have map for each sum, which produce we use all the elements. Here we extract a subset of the vector. Yes?
Why do you use parentheses in this syntax and not brackets? Because you have no point.
Because I can also.
Okay.
Because I can also. still it works.
And
Yes.
the par function can be used with
Yes. You can use par function here. I can use par function here, so the filter with the we will do in parallel. But notice that the type has changed. Now I am not a vector anymore. I have a par vector,
And that means?
parallel vector.
Okay.
Just because Scala is statically typed and strongly typed, and each things at one time.
Yeah, so I think I'm still wondering about the loop. In this way, we can show the for properties. But how about the while?
Why?
Loop while.
One.
While.
Until.
Yes.
Until. So
Until what?
I mean the loop.
Yes.
You can use the while something loop or repeat something or for.
Yes.
And for the next.
But tell me an example when you need a while.
Something we don't know how many.
Okay. I will show you.
Yes.
Maybe I can't remember if I will show you. Oh yeah, it just will explain you that something in the presentation you will see an equivalent to while.
Okay.
You can find the first value that satisfies a condition with the function find. We then find modulo underscore modulo 2 equals 0. It will find the first element that will satisfy this condition. And look, 30 is sum 0. And this is why I love Scala.
This is why
I love Scala. Because filter can find or cannot find a result. Okay? If I put here I have to remove one. I have dropped the first element, which is 0, because 0 modulo whatever, it's always equal to 0. So I dropped the 0. So I have a vector, my V10 is not V10, is V9, starting to 1 to 9. Okay? And here I will try to find modulo 20,000 equals 0. There's no chance I find it in this vector. And the result is none. I have no result. It's really different than in every language I know. Here, I have no result. The result is none. There is none value that satisfies this condition. So, here, typically, the return type of this function is option of something, because this function can return two types, sum of an element, or none, there is none element. Sum means I have one element and the value is inside the sum, or none, I have no value. It allows you to easily avoid the non-commuter exception. You do not return a value that does not exist. You say, I have no value. Okay? The same way we have find, we have count. count the number of elements that satisfy the conditions. And this works exactly in the same way. Always the same way of working. We then count modulo 2 equals 0. That's 5 elements in my vectors. And you notice all the functions are simple to use, simple to remember, because you just say what I want to do. I want to count. Oh, okay, just count. They always are like this.
And if I want to sort,
You sort.
If you want to make a coffee,
it's about that.
Yes, if you want to make a coffee, don't use my coffee. It won't work. But yes, oops, là. A difficult one. Fold left and fold right. Apply an operation to successive elements of your collections. Going from left to right if you use for left, from right to left if you use for right. Starting with the value Z, which you learned in his first problem thesis. So here, we then fold left 0 underscore plus. I want to do the sum. I take 2 elements, I do the sum, and I start with the value 0. It will compute the sum. But to see how it works, I will explain on this example. I define a function myMean, which takes 2 parameters and says I am comparing it with y, and then returns the good result of mean. So every time I call this function, I will have a print to trust the execution of the fold left. So you can see how it works. Maybe I should print before. I will print V10 shuffle before. So my vector is 3, 5, 4, 7, 2, 8, 0. Okay? And I apply the function fold left. I use fold left on my vectors with the function myMean, which means I will compare. I will compare with an initial value. For example, here 1000. It's not a good way to do. And for every element, I apply for every couple. Then I need 2 values to compare. To apply for left, I need 1 value, which will be the 0, and the 0 will take the first value, do the result, do the function. There is 1 result. This result will be used after. So here, I'm comparing first time I run for left. I'm comparing 1000 with 3 because 1000 was the initial value, and I use myMean. So this will return to 3, and I use the second element 5, and I compare it with the previous result. So the previous result was 3. So myMean of 3 with 5 is always 3, and I take the second element and comparing. The next one, comparing. Next one, comparing. Next one, comparing. But here, there are the date of the result because 2 is lesser than 3. So I take my initial value. With this initial value, I take the first element of the vector, I apply this function. This produces a result, and this result is used to calculate the next value of the next vector. Right? Yes? No? I can do it with mass, but this is equivalent to say I test with my initial value. I calculate the mean initial value, the first element, Then the result of this, I calculate the minimum with the second element. Then I calculate this with the third element. Then etc. Okay? It's quite simple. Also, the fourth right exists. You can start from the left or from the right. This is what is called also a reducer. We are reducing our value to 1. But here, we need to provide an initial value. And sometimes, we don't want to provide an initial value, or sometimes, the neutral element of your operation is very difficult to find. So Scala has also the radius left and right function, which is exactly the same that radius left or radius right, but with the initial values, the first value of your correction. So you do not have to provide here a natural element or an initial value. This is exactly the same, but this will disappear and will be replaced by 3, because I take the first element as an additional value. Okay for everybody? Yes? I didn't say that in my collection I can find I need to repeat it. There is a min function. There also are max function and sort with function. Here I sort my vectors with the function lesser than. And there is also one function is what is union that joins two vectors into one. So here I join V10 and V10 shuffle, and I sort it with lesser than, and that produces by vector 2 times. Okay? With this, you can do all you want. We have several other functions, but I don't think it's time to bother you with this function, because I want Yannick to present a little also, and I think if I introduce too much function, you will overlap all the functions. You will don't remember. Okay. But no, for time, there is a take while or a drop while function. Take x element while this condition is satisfied. Drop x and drop every element until a condition is satisfied. We have the split I, as I showed you before. And I have to show this. The zip function. I need to quit V10 and V10 shuffle because I can't remember it. And I will quit V10 zip VLAN shuffle. And you know what is a zip? Here we have exactly the same. We take one collection and another collection and mix it together. So, if I print the first vector and the second vector, zip will generate a sequence of the with the all elements collapsed together.
They must be the same size.
I can't remember. I think no, they must not be the same sign, but if they are not the same sign, the longest one will be primitive. And we have exactly the same thing that with zip with indices. So you can zip with indices. That means I do not provide, because with zip with index, you don't need a second vector. It will generate the sequence of first vector with the first one index, second vector of this with the second index, etc. Magic to do this. Sometimes it's bad, it might be useful. So, I think maybe you have choice. Maybe you can practice on this example now, or maybe you can practice it later on, and then if you can't practice now, I will answer to your questions, or Yannick will start to speak.
So if we want to practice later, how will you do?
How can you do?
Yeah, because I mean, for example, after the lecture, I want to go home and maybe practice.
Yes. If you want to practice at home, just download Spark Notebook and use the file IP.
But we need to install something in this computer.
Download Spark Notebook. It's very simple. You go to Spark. Spark Notebook, I think. You go to this. Very simple. You have to choose what version you want. I want notebook version 0.0, so Scala version, I want it to 2.11, etc., etc., etc. And then download. You have to fill your email, but you have to just click on download. This will download here a zip archive, unzip, run, it runs. It's quite simple. And the magic of that you have inside a Spark also. So it simulates that you have a cloud computing to do something. You can run Spark in this notebook. sure it will not be efficient. But to test and to practice is really just what we need. But I will send an email to Dominique, and Dominique will write on the website of TORUS website.
To explain.
To explain and to download the file, because my FD person will soon be replaced by the usual index file. And but I will provide the file to Dominique, and it will right click to the website, and so you can practice. But he will put the site in production when all indicators are available. So fill your ID cards. Any questions? Well, thank you. Your turn. Tu vois, just to precise, you do not have to download a virtual machine to install Spark Notebook. Just install it, and it will work in every environment. So you do not have to create a virtual machine to embark this. We have created a virtual machine because Perl is it. But indeed, we do not need it. And I need Chrome to fix the problem of image size.
Oui, après, il me dit on fait tout depuis gros.
C'est un couple. Et c'est un couple de toi, ce que tu voudrais, underscore, alors, je crois que c'est